Great, thanks everyone. Now I can only see my screen here, so I can't see everyone's questions. So yeah, please put them in the chat, and everyone will let me know. At Livestock Water Recycling, we are using our water treatment technology paired with data analytics and machine learning to modernize an old-fashioned agricultural practice of storage and land spreading large dilute volumes of livestock waste and manure. If you heard my 60 seconds, I said that 700 dairy cows make as much waste, liquid waste, as the city of Red Deer. And right now, this is not being treated on site. Manure lagoons are actually filled with dilute liquids that are mainly water, 95% water and only 5% manure solids. This makes it difficult and extremely expensive to store, to move, and to land spread. The nature of this liquid can result in runoff from onto lands, into waterways, and we want to preserve our natural environment and waterways. At LWR, we know that manure is an essential natural fertilizer containing all 14 nutrients required by plant growth. And we are trying to extract that from those dilute liquids. Our technology platform is a small water treatment plant to be installed on farm and receive manure directly for treatment before it ever goes to storage. From that, we create 2 fertilizers and clean potable water. Our technology platform is manufactured in 5 standard models. We build everything here in Calgary and ship worldwide for installation. We've recently partnered with a Calgary manufacturing company to help us scale. Our technology is unique in that it is automated and uses sensors to collect data and allow operation by smartphone. It concentrates wastes into those 2 distinct fertilizers that I mentioned, and healthy, clean, potable water. Our clients are livestock farms in dairy, hog, and beef production, as well as facilities with food waste, and importantly, anaerobic digesters. As I mentioned, we have systems installed across the United States, into the Middle East, and have started working in the UK and EU this year. Now more than ever, there's a tremendous opportunity coming to assist the agricultural industry in this energy growth opportunity to create value from bioliquids. And our technology enables this. We can extract solids to be used for renewable natural gas feedstock while reducing on-farm greenhouse gas emissions by up to 82%. We work to connect farms to the energy economy by combining our technology in 3 ways. Prior to an anaerobic digester, we extract volatile solids to increase biogas output by 2 times. After an anaerobic digester, we clean the liquids and create fertilizer for crop production. And in many cases, we can combine multi-unit systems into 1 digester in a hub and spoke model to, again, increase the biogas output at the hub digester and create the best possible value proposition for many small farms. We use our digital platform to enable farms to make informed decisions about whether their solids and liquids need to go onto cropland for soil regeneration, over to biogas digesters for renewable natural gas production and increase their economy on their farm, or to use that in valuable other ways on the farm, and to use the clean water in the best possible way. Our vision of lagoon-free food production turns this into this. At LWR, we are on track to recycle 1 billion gallons of manure this year, directly impacting 10 of the UN Sustainable Development Goals. And we are looking to grow that into 1 trillion gallons treated by scaling geographically through strategic partnerships. Thank you very much. And please let me know if you have any questions.
Thank you so much, Karen. That was fantastic. We do have some questions coming in, and given you concluded with strategic partnerships, I thought it was interesting to note that the 2 questions are from other ventures, wanting to potentially collaborate or learn more about what you're doing. So the first one is from Marnie Lett, and it sounds like she would love to know more about your fertilizer products. So what specifically you're selling?
Sure. So I'm just going to go quickly back to our three products we create. So our liquid nutrient is on the top there. 17% of our full volume ends up in that state. That contains micronutrients, so valuable ammonium, potassium, magnesium for soil regeneration. And then our 8% solids is where we see the organics. So we'll see all the carbon, 99% of the phosphorus, and then as well the organic nitrogen in that piece. Now that solid can be used for fertilizer in crops, feed crops, or that solid can also be used for renewable natural gas production, depending on the best possible value proposition for the farm.
Great. Next up from Rob, he's saying that they are interested in helping to increase the value of your residual biosolids from this process. I believe Rob is with Airterra. And here a follow-up question from Rob: are there biosolids resulting from renewable natural gas?
Yes, so definitely we have the same production. When we look at after the digester, we still produce those same three outputs. So we still get a liquid nutrient that's very high in micronutrients, and then a solid. We still have solid phosphorus coming out of the production. So a lot of the carbon is consumed through the anaerobic digestion process, but not all, of course. They're only 50 to 60% efficient. So we do have carbon and all the organic phosphorus and organic nitrogen come out the back end of digesters. So we segregate that, and then it's available as a fertilizer product. We would absolutely love to partner with people on that fertilizer product to create more value, a more valuable feedstock for improving the feed crop production of our farms. Feed crops are the single biggest expense for livestock producers. So anything we can do to increase their feed crop production is what we want to look at.
Great. And I'll move on to the next question in a second, but Rob has another follow-up. Could biochar be co-composted with the solids?
I love biochar. That's you're speaking my language here. Yes. The short answer is yes. And please reach out to me because I have a whole bunch of ideas around. We have one of our farms that is a pork producer right now, and they are producing a biochar product out of their gasifier. So we really like to engage in co-composting or anything we can do there. Yeah, definitely.
Sounds like you both will be chatting later. So next up, Abdallah was interested about the fate of heavy or toxic metals such as arsenic in this process. So what happens to them?
Yeah, it's a good question. And, depending on what we see on the farm, that really tells us, part of the reason why we digitize the whole footprint of where everything is going, we can tell where we have any heavy metals. We would have that end up in the solids. The majority of the time would end up in the solids, and then we could deal with it accordingly if it was problematic at that state. We have not found problematic heavy metals at any of our farms so far, but we have been very careful in looking for that. Other problematic substances as well, like PFAS, and people on here know what I'm talking about, but we're not seeing that on farm. We're seeing a really pure waste. But we are looking out for it, definitely.
Okay. Next from Helen Hugh, what are the top 2 uses for the recycled water?
Number one, I would say, is cleaning and flushing. When we flush the barns more often with cleaner water, we see better production by I'll speak specifically about dairy farms, but every other farm is seeing the same thing. When you have cleaner bedding for the animals, they lay down more, which means they gain weight better, and they milk better. So they have more milk production the more they lay down. So using that clean water for flushing rather than using their lagoon water for flushing, which is what they do now, we see a way cleaner environment. We see increased productivity, as I mentioned, reduced disease on the udders and hoofs, and overall herd health is better. Somatic cell count is improved. So overall, we see flushing with that is a really good value proposition for the farm. Number two, I would say, is probably cow cooling. In drought-ridden areas, we do have some farms using it for drinking, and then of course irrigation. Drip irrigation is really important in California. But number one is just carefully protecting the herd.
Mm-hmm. Okay, and thank you. And lots of questions coming. Okay.
Okay.
Hold on. One note from Mike Mannion. He's left you his email. He had to jump off the call, but wants to follow up. I'll pass that on to you, Karen, in a second. Marnie is asking another question. Are you working with any organic dairies?
Yes, we have one right now that we're working with. We're working on a number of projected organic dairies. So that's definitely in our plans going forward. One currently right now is working to figure out how the fertilizer and all plays into their value proposition. So one now, lots projected.
Okay, and again, following up, just asking if there's any specific challenges with the organic dairies.
Yes, organic certification. There's any of you who are working on that, you know, there is some differences about what you can put on the crop. Once the dairy cow eats it, then the manure becomes organic, no matter what is put on the feed crop. But that seems like a loose area. So we're just always working on organic certifications to make sure that we're meeting what everyone needs.
Okay. And a quick note from Abdallah. He says we could have a solution to extract the heavy metals from the solid. They have a technology that is able to take a solid residue, convert it into valuable products. And again, you've got an offer for collaboration and an email.
Absolutely. Absolutely.
So this seems like a pretty popular session here. Lots of questions. I realize now I did not write down the time. We have to jump to the next session. I feel like we need to wrap this session up. If anyone has a final question, ask it now. Otherwise, I think we should probably start migrating back to the main stage. Do you have any final words, Karen?
Yeah, I just was thinking, looking at the clock, I think we were supposed to be back by 10:10. But
okay, I think you're running late though. So.
Oh, okay. Yes, please reach out to me, LinkedIn, or on my email address. I'm going to go back to, or I'll go forward to my last slide, because we are really engaged in all the ways that we can create a better fertilizer product, a better carbon sequestration on the land. We see farms as a soil sink, as a carbon sink on their soils. So we really are working on that. I mentioned in another session that we're working on the Carbon X Prize application right now. So please reach out to me if you want to engage on that as well.
Okay, and I believe we'll be following up with the email addresses of the pitching ventures. So if you didn't catch it off the slide, I just look at the follow-up email from the event. Okay, I think we are moving on. If everyone could go back to the main stage, we will see you there. And I believe it's the panel discussion. Thank you so much, Karen.
Thank you.
Okay, take care.
Thanks,
Bye.
everyone.